Hi everyone, welcome back. In this lecture, we're going to explore a core concept of object-oriented programming called inheritance in Python. This is one of the most powerful features of OP, and it helps us reuse code, reduce duplication, and organize programs in a clean and logical structure. Let's first understand the real-world scenario before diving into the technical part. Imagine you are building a software system with multiple user roles like students, teachers, and administrators. Now all these roles have some common things like a name, an ID, maybe email, but each of them also needs unique behaviors. Students can enroll in classes, teachers can grade assignments, admins can manage users. So should we write all that code separately for each class? That would mean a lot of duplication, and duplication is bad. Instead, we use inheritance. We define a base class, maybe call it user, which contains all the shared attributes. Then we extend it into specific roles, student, teacher, and admin, and add unique behaviors there. This is exactly how inheritance works in Python. It allows us to define shared behavior in a parent class and extend or customize it in child classes. So, what is inheritance? In Python, inheritance is a feature that allows one class, the child class, to inherit methods and properties from another class, the parent class. In simple words, inheritance allows one class to reuse the code from another class. This helps us reuse code, make changes in just one place, and organize our program into a hierarchy of classes. So the parent class defines the general behavior, and the child class can either use it as is or override it to change how something works. Before going further, let's explore the relationship between parent and child classes. A parent class, also called a base class or superclass, contains the common code that can be shared. Think of this as the general template for a group of similar objects. A child class, also called a derived class, inherits from the parent. This means it can use everything defined in the parent class, but it can also add new methods or attributes, override existing ones. So, why use inheritance? Let's take a moment to understand why inheritance is so useful. First, it saves time. You don't need to repeat code. Second, it makes your code clean and organized. You separate the shared logic from the specific ones. Third, if you need to change something in the shared behavior, you just change the parent class, and the change applies everywhere. This is powerful when you are building real-world software with many user types. Now let's take a look at the syntax of inheritance in Python. We start by defining a parent class. This is the base class. We use the class keyword, followed by the class name. Inside the class, we can define a constructor method using double underscore init. This constructor takes parameters and stores them using self. The parent class can also have one or more methods, which are reusable actions that any child class can access. Next, we define the child class. The syntax here is very important. After the word class, we write the name of the child class. Then inside parentheses, we write the name of the parent class, from which it should inherit. This tells Python, please copy everything from the parent into this child class. Now inside the child class, we can do two things. We can write a new constructor, and we can write new methods that only belong to the child class. If we define a constructor inside the child class, we usually want to reuse the parent's constructor first. This is done using a special function call, where we tell Python to call the parent's init method and pass the required values. This ensures the base class setup is complete. Then the child constructor can add new attributes or perform additional logic. Once inheritance is in place, the child class can do two things. It can use the existing methods from the parent, or it can override a method from the parent by redefining it with the same name inside the child. This allows you to customize behavior while still keeping the base structure intact. Now, we learned the syntax of inheritance, how a child class can reuse and extend the behavior of a parent class. Now let's apply that knowledge and walk through a simple and clear example. We'll take a vehicle class as our base and then build a car class that inherits from it. We start by defining the parent class called vehicle. This class will have a constructor which accepts two pieces of information, the brand and the model. Inside the constructor we use self to store those values, and we'll also define one method. Let's call it display_info. This method will return a simple string that prints the brand and model. So the vehicle class acts like a base blueprint for anything that's a type of vehicle: cars, bikes, trucks, anything that has a brand and model. Now let's define the child class called car. This class will inherit from the vehicle class using the syntax we already learned. That means in the parentheses we write vehicle. Inside the car class we define a constructor again, but this time we need to call the parent constructor first using superMethod.init method. We pass the brand and model to the parent, so it sets those values. After that, we can define new attributes specific to the car. For example, the number of doors. We'll also add a new method called car_info that uses all three values: brand, model, and doors, and formats them nicely. Now, when we create a car object, we pass all the details and we can call both methods: the method inherited from the vehicle class and the new one defined in car. This proves that inheritance is working and the child class is extending the parent. This is a clean and complete example of inheritance in Python. The car class reused everything from vehicle and added its own flavor. In the next lecture, we will learn inheritance with coding example. Thanks for watching. I will see you in the next lecture.